How's it going? My name is Daniel Labunsky and I'm an undergraduate researcher at San Jose State University. I'm here at SSRL, the Stanford Synchrotron Radiation Light Source at the SLAC National Labs, and I am currently standing beside Beamline 10-1. First and foremost, I would like to thank my PI, Dr. Abe Walcott, as well as Dennis Nordland, the gentleman that got us the opportunity to be working here at SLAC. It's a really, really amazing opportunity and I'm very grateful for it. Also want to thank NIST, NIH, the DoD and DOE for supporting our research and for funding this and other great research. So just for a second, I want to discuss what this is behind me here, the TES, the Transition Edge Sensor. I'll discuss for a moment. It's just a really rare and special opportunity, so I figured I'd take it. Basically what this device is an ultra-sensitive thermometer. It consists of 240 pixels, which are maintained at an ultra-low temperature, near 0 Kelvin, very near 0 Kelvin. And essentially, if you look at a graph of the resistance of a superconductor plotted against temperature, you'll see that at a certain temperature range, the graph of the resistance is fairly flat, and then as it gets cooled and cooled, there's a sharp peak, and then it flattens out again when it's in the superconductive state. So what we're taking advantage of here is that very, very sharp slope. We maintain the temperature of the TES detector at a temperature where the superconductor in question is in its transition state. So it's right between being superconductive and just conductive, which makes it a really, really sensitive thermometer, effectively. So each of these superconducting pixels, if you will, are inductively coupled to a SQUID, superconducting quantum entanglement detector, no, interference detector, excuse me, which is a sensor that is sensitive to a resolution, a magnetometer, which is sensitive to a resolution of about 5 attofarads, that's 10 to the minus 15, and that is really what is on the kind of receiving end of the detector. And effectively what we're using this for is we're bombarding a sample with X-ray photons, and these photons interact with the electrons in the atomic structure of the samples that we're putting in, and they are emitted out with a certain sort of energy signature, and that energy signature is then read out as a change in temperature in the TES detector, and this allows us to get a good idea of what sorts of elements and what sorts of bonds we can find in a sample. And that pretty much covers it as far as the elevator pitch for the TES. This beamline also has an XAS, X-ray absorption spectrometer, and XPS, X-ray photoelectron spectrometer. And these are all used for essentially determining bonding structures and atomic structures of certain sample compounds. So again, I'd like to thank everyone that was involved in giving me the opportunity to come here, and I hope you all enjoyed my brief little chat about the Transition Edge Sensor. Cheers.